Very good evening to all members. So I welcome you all for the last final presentation under latest research trends in mechanical engineering. In today's seminar presentation, we are going to discuss about importance of task scheduling in multi-robot assembly work cell with genetic algorithm as a primary tool. By means of case study, we are going to discuss in the following the consecutive slides. So, what are the session objectives? Before moving to the main subject presentation, let us have the session objectives very clear. So, the use of genetic algorithm, I mean to say evolutionary computational algorithm. So, with the use of genetic algorithm, so we can go for effective assignment of task scheduling in multi-robot assembly cell by considering the following objectives, say enhancing the operational efficiency, production flexibility, and overall productivity. With the help of genetic algorithm, easily we can assign the task for each robots by defining the task sequence and also the possible kinematic movement of the robot so that the manufacturer can able to significantly reduce the cycle time and the resource constraints within the assembly cell. So let us go with the problem statement. So task scheduling in a multi-robot assembly cell using genetic algorithm involves the following thing: optimizing the sequence and allocation of various tasks to be performed by each uh, parallel robotics missions inside the assembly cell by considering the common objective minimizing the total production time, that is make span time, by strictly adhering to various assembly precedence constraints by avoiding the collision within the assembly cell. GA is more highly effective for solving NP-hard problems, that is nothing but non-polynomial, non-deterministic problem. So since it has large enough search space for obtaining the near optimal solution, so GA is the most fundamental, more suitable method for solving problems related to task scheduling, task assignment under robotics and automation. So what is exactly a multi-assembly work cell? Typically, a multi-assembly work cell will have the following entities: parallel assembly stations accompanied by one or more robots, so which performs various monotonous repeated tasks like pick and place operation, welding, inspection, and fastening. So these are the common thing that is presented in multi-robot work cell, that is assembly cell. Now let us go to the main uh, the subject thing. What is exactly the task scheduling problem? So the three main things to be defined here: the sequence of various job operation, assigning a different job to various industrial robots, then calculating the time for each individual task. So these are the main input parameters that has to be defined in the genetic algorithm. What are the typical objectives uh, for a task scheduling operation? So minimizing the production completion time, total production completion time, maximizing the percentage of use of industrial robots for performing the automation task, balancing the workload across various robots, reducing the temporary work in process buffer, minimizing the energy consumption, avoid various deadlocks and the over collusion inside the shop floor system. So these are the general objectives for task scheduling problems. What are the various key limitation or key constraints? So precedence constraints. Say if I have three different part number A, B, and C, So part A has to be scheduled first before going for the next operation, welding operation. So all the operations, we need to do it in an orderly manner without changing the sequence. So this is what precedence constraint. Resource constraint. So only one robot can able to do only one particular task at a time. Next one is travel and handling time. So each robot motion time between parallel station is recorded every subsequent iteration, and also the tool changeover time between parallel stations. Then synchronization constraints. If there are two robots working together, both must have equal coordination and support. In such a way, we can drop the collision avoidance problem. Then deadline and cycle time constraint. So every product must finish within a given cycle time. So these are the constraints that are to be added in the algorithm, the genetic algorithm, while solving the problem. Let us discuss various solution methodologies for a task scheduling problem for multi-robot assembly cell. So conceptual model formulation, that is mathematical model formulation. Problems like job shop scheduling problem, flexible job shop scheduling problem, resource constraint project scheduling problem. So these practical applications can be solved with the help of the mathematical formulation. What are the common approaches for task scheduling? Say rule-based heuristics, which are highly relatively very simple and fast. So the following are the standard algorithms. First come, first serve scheduling algorithms, shortest path or shortest processing time algorithms, priority rule-based algorithm. So these algorithms somehow may be easy to implement, but we may not able to get the optimal solution for complex, high complex problems in real time. Next alternative is using optimization methods like mixed integer linear programming, constraint programming. But there is one disadvantage. So for larger size problems, we can't get optimal or near optimal solution. Computationally, it is very tough. It may take more number of time to solve the complex problem. Next one is meta heuristic. Popular methods like genetic algorithm, ants colony optimization, particle swarm optimization, and simulated annealing. So these methods are well suited to handle the complex constraint problems, but we may not able to get the global optimum solution. Only near optimal solution we can able to attain after running the problems for several number of iteration or steps. The next one is agent-based intelligent scheduling problems. So these are the four different variety of solution methodologies. So out of which today we are going to discuss genetic algorithm as a case study for task assignment scheduling problem for multi-robot assembly workshop. Let us directly get into the case study of the problem. So in this problem, we are going to consider three parallel robots. Number of assembly tasks is considered to be 6. Each task has a unique process timing. The main goal is to reduce the total completion time, that is the make span time. So the chromosomes can be represented as task assignment to each individual robots. So the genetic algorithm, the main ideology is from the evolution theory as suggested by Charles Darwin. So, so based on the evolution theory of computation, so the genetic algorithm can be solved more near optimally in order to obtain the final solution for any type of the practical problems in actual scenario. So these are the task data as listed here. So the number of tasks in various assembly cell is considered to be 6, and each task has a unique process timing that has been tabulated here for your kind reference. Now, sample chromosomes can be represented by taking the following assumption as a rule of thumb. Each gene position in the chromosome is equal to the number of robots assigned to the task. So this is the sample chromosome array that has been given here. So it shows a clear meaning in the following slides. So T1, the task number T1 is assigned to robot 1. Similarly, task number 2 and 3 assigned to robot 2 and 3 respectively. So this is the meaning of the chromosome representation. The previous slide, they are given 1, 2, 3 and repeatedly 1, 2, 3. So this clearly represents T1, T2 and T3. So each assignment of task represents the use of individual the robotic manipulator in respective assembly work cell. And the formula for calculating the fitness function, so inverse of the total job production time, that is makespan time. So the makespan time is nothing but the maximum total time of each robot, maximum available total time of each robot. By summing up the maximum total time in each assembly station, we will be able to get the maximum the makespan time. So these are the general steps in genetic algorithm. So initialize the random population, then followed by that evaluate the fitness function, select the chromosomes randomly, perform the crossover operation with the help of the single point crossover G operator, then do the mutation process. So the purpose of mutation is to improve the solution by randomly reassigning the robot by performing the task. Then repeat the same operation for n number of generations. Then finally return the best solution out of the available different alternatives. Let us see sample GA algorithm using Python programming. So these are the various input, the problem dimensions to be given. So the number of tasks is initialized to be 6. Number of robots is 3. The task timings are given. Then population size, number of generation count, then mutation rate. So everything has been given in a pre-standard manner. So the first thing is we need to design the chromosome. After generating the chromosome randomly, find out the fitness function for each chromosomes. Then calculate the makespan time. Along with that, what is the fitness function by taking the formula inverse of the makespan time. Already in the previous slide, I have shown you the equation for finding out the fitness function, that is 1 by makespan, inverse of the total job completion time. So find out the fitness function for each chromosomes, randomly generated chromosomes. Then select any 2 chromosomes out of the available population, perform the crossover with the help of the GA operators. Then after doing the crossover operation, do the mutation by randomly realigning the solution to the next stage. Then after performing the mutation, identify the best solutions that are available and try to update in the candidate list the available best solution. Then again run the same program for the another possible combination of iteration. Find out at last what are all the best task sequence, best make span time. So we have to print that output by defining the print function. So this is the sample output that has been displayed here. So for first robot, task number 1 and 4 is being allocated. So the total assembly time, the production time is 7. For the second robot, task number 2 and 6 is assigned for the second robot. The total job completion time is 8. For the third one, T3 and T5 is the task assigned. So 12 is the total job time. For see, this is nothing but the individual station time, 7, 8, and 12. So out of which we have to find out what is the maximum available make span time. So 12 is the best solution that has been obtained here. So what is the inference of this method? So using genetic algorithm, we can able to find out which is the most feasible best solution out of the several task assignments. So with this, I conclude the closing remark for today's seminar presentation. So generally, task scheduling or job scheduling in a multi-robot work cell plays a high important critical role in achieving the higher productivity in modern manufacturing systems. So by effectively coordinating various multiple robots, so we can optimize the scheduling process by minimizing the idle time and balancing the workload effectively across various assemblies. Use of intelligent scheduling strategies like priority-based dispatching rule, heuristic methods, or optimization algorithm. So whatever the method, so that will aim for efficient resource utilization by avoiding the scheduling conflicts and deadlocks among various robots that are parallelly processed within the assembly cell. So with this, I conclude the number of the lecture that has been delivered under the common theme latest research trends in mechanical engineering, including the today's presentation also. So with this, I finally close the lecture series. We will meet in the next upcoming new theme of topics. So that will be updated later in due course. So once again, I thank all the student members, industry professionals, and faculty members for continuously supporting in each and every occasion. So once again, I thank all the members. We will meet in the next subsequent the lecture series. So thank you all.